good afternoon to all of you, dear students. So, what we are going to do today, if you try to recall which topic was discussed last time, means yesterday. Yes, we discussed apparent depth and real depth. Apparent depth and real depth we discussed yesterday. So, what we are going to do today, we discussed only one numerical in last session. So this means today we are going to discuss some numericals based on apparent depth and real depth. Okay, so now let's start the session, and before starting the session, a quick revision of the formulae of apparent depth and real depth. So I'm writing the first formula which we used here. The first formula is A mu m, where it is m is medium, the refractive index of the medium in which the object is lying, and it is equal to real depth upon apparent depth. Okay, so this one formula we discussed, and second formula which we discussed, that was normal shift. How much object is raised, how much, okay, it appears raised from the bottom here. So normal shift is equal to here, what do we write here? Yes, try to recall, 1 minus 1 upon refractive index of the medium in which object is lying here. So what do we write here if you try to recall? Yes, anyone? Yes, any one of you? So here normal shift is equal to, here we write real depth. So these two formulae we discussed last time. So today we are going to discuss the questions based on these two formulae. So some questions will be discussed and then some questions will be given to you for homework. And I'm sure you are going to enjoy this session. Now let's start the session. So the first question is now. So I'm writing the first question here. So question number 1 of the day. So the question is, that's a glass block of 3 centimeter thickness. So thickness of the glass ball is given. So I'm writing here, given thickness of glass slab. So thickness of the glass slab is given 3.0 centimeter. So the question is, a glass slab or block 3 centimeter thick is placed over a stem, or we can say it is an object or a coin is there. Okay, anything can be there, a stamp or coin or any dot. Okay, and you have to find out the height through which the image appears raised. If object is here, so how much it appears raised from the bottom? This we have to find out. Okay, and what else is given here? Refractive index of the glass is given. The refractive index of glass, this means mu g is given, and this is 1.54. Okay, now to find, we have to find out the normal shift. Now solution. So either we can go for this formula or directly we can use this formula. तो दोनों में से कोई भी फार्मूला हम इसमें यूज कर सकते हैं. ठीक है. So normal shift के लिए फार्मूला क्या होगा? This is, since we know that, so normal shift is equal to real depth 1 minus 1 upon refractive index of the medium, and here medium is glass. So here normal shift we have to find out. Real depth is how much? 3 centimeter. It is 1 minus 1 upon 1.54. Okay, 1 minus 1.54. So here we can find out, this will be 1.54 minus 1 upon 1.54. So we can solve it. Now try to solve it. इसको solve करिए कितना आता है देखिए. So this comes out to be 3 into, here it will be 0.54 and here 1.54. Point cancel. What do we get here? So 3 4s are 12, 3 5s are 15 and 1 16. 162 upon 154. So when we divide it, what do we get? We get 1.06 centimeter. So this is the normal shape. The object appears raised how much? 1.06 centimeter from the bottom. Okay. So directly we can use this formula to find the normal shape. Now after this, next question. So may I rub it now? So I am going to rub it. Now second question. तो सेकंड क्वेश्चन हमारा है, सेकंड क्वेश्चन है, द फ्लोर ऑफ ए वाटर टैंक appears at a depth of 2.5 centimeter. Appears, so this means apparent depth is given. So apparent depth of the floor of water tank is given how much? 2.5 meter. So here I am writing given, then to find, and then solution, right? So here again I am reading the question. The floor of a water tank appears at a depth of 2.5 meter. If the refractive index of the water is 1.33, find the actual depth of the water. Okay, actual depth of the water. So here apparent depth is given. Apparent depth is, it is how much? It is given 2.5 meter. 2.5 meter. A refractive index of water is given. So here A mu G 1.33. Refractive index of water, here it is W. Water is given. To find actual depth. Actual depth of water. This we need to find. Now again using, since we know that, because we have to find actual depth. So direct we can use simple formula here. So since यहाँ पे लिखेंगे mu W and here it is real depth upon apparent depth. Okay. So now what is there? So this is 1.33 and here real depth is we have to find out, and here apparent depth is 2.5. So therefore real depth will be 1.33 into 2.5. Multiply this and what do we get here? इसको multiply करेंगे and what do we get? Just multiply 1.33 and it is 2.5. Okay, 25 3s are 75, 25 3s are 75 and 7 82, 25 1s are 25 and 8. 25 and 8, how much? 33. And the point will be after 3 digits. So answer comes out to be, real depth comes out to be 3.325 meter. Okay. So here real depth of the water is 3.325 meter. I am sure you must have. Now question number 3. So third question we are going to do, and what is given here, I am reading the question and in the meantime you can write down in your notebook. So the question is this, a postage stamp placed under a glass. A postage stamp placed under a glass appears raised by 8 millimeter. Appears raised by 8 millimeter. So this is the surface here and glass slab is placed on it. This is the glass slab and the stamp is here. It appears 8 millimeter raised here. So this is 8 millimeter. So this appears raised. It is lying here but it appears here. Okay. Now if refractive index of the glass is given, the refractive index of the glass is given we need to find the thickness of the glass slab. तो हमको ये find करना है. We need to find this thickness of the glass slab. ये हमको find करना है. Okay. So this is the normal shape, but we don't know how much is this. ये कितना है? ठीक है ना? ये हमको find करना पड़ेगा. So let this thickness be x. तो ये कितना हो जाएगा? ये thickness x हो जाएगा. This is 8. So this will be very good x minus 8. It will be x minus 8. So now I'm writing given. So normal shift is given. Normal shift is 8 millimeter and refractive index of glass is 1.5. It is 1.5. To find thickness of glass slab, और इसको हम क्या कहेंगे? This means real depth, or we can say real depth. We need to find. हमको ये हमको find करना है. Real depth हमको find करना है. Okay. Now solution. तो simple formula use कर लेंगे इसमें. Since we know that the refractive index here of glass is equal to real depth upon apparent depth है. ये फॉर्मूला करेंगे यूज. तो इसमें पहले हम लिखेंगे let thickness of glass slab be x. ये हमारा x हो गया. Okay, and normal shift, it is normal shift is how much? 8 millimeter. So therefore we can find out apparent depth. ये apparent depth आ जाएगा. Okay. Therefore apparent depth I am writing yes पूरा लिख देते हैं. Apparent depth. ये कितना हो जाएगा? Yes, apparent depth will be how much? Yes, it is written x minus 8. X minus 8. Now just putting the values here. The refractive index of glass, it is how much? 1.5 is equal to real depth हमको find करना है. It is x and apparent depth हमारा आ गया x minus 8. Now we have to use mathematics. Mathematics को use करेंगे and solve करेंगे. So cross multiplication. So it will be 1.5 x minus 8 is equal to x. And here when we multiply, ये हो जाएगा आपका 1.5x minus 1.5 into 8 is equal to x. And here कितना हो जाएगा? Yes. So it will be 1.5x minus 1 to 12 because 15 8 is 120 and the point is after 1 digit 0 gone. It is x. जब इसको x को इधर लाएंगे ट्रांसपोर्टेशन. So 1.5x minus x is equal to 12. And देखिए 1.5 minus 1x minus करेंगे. So what do we get here? Yes, 0.5x is equal to 12. Therefore, x will be 12 upon 0.5 or what do we say? कितना आ जाएगा? This will be 120 upon 5. So therefore, x will be 5 to the 10 and 5 for the 20. Okay, so 25. So it is 24 millimeter. So now we can get here. So this is the x and x is the thickness of the glass slab. We can say, we can write down here. Therefore, thickness of slab is 24 millimeter. Okay, or this is the real depth of also. Real depth means real depth of the postage stem. And if you are asked to find out the apparent depth, so x minus 8, तो 24 minus 8 कर देंगे तो हमको आ जाएगा apparent depth भी आ जाएगा. So this way we can solve the numericals also. So we have done 3 numericals, and this is a very good numerical because it is giving you knowledge and then it will help you to solve other numericals. Now next question, and before that I am going to rub it. Okay, before rubbing, yes, note it down. इसको note कर लीजिए जल्दी से, because this is a good question. Yes, now we are going to do the fourth question. So what is the fourth question? So first of all, again we are writing here given, then to find, and then solution. Then solution, right? The question is this, that there is a pond, and in the pond there is a fish. Pond में fish मिलेगी, तो pond में fish है. So there is a pond, and this is the interface here, and this is the pond here. Okay, and in the pond there is a fish. Pond में एक fish रखा हुआ है यहाँ पर. So here it is the fish here. So at this position fish is there, and the distance of the fish here from the interface is x. ये जो distance है ये दे रखा है हमको x. So x is the distance, means depth. It is the depth of the fish from the interface of the two media. Here it is air. It is air, and this is water. Okay. Now bird is there. Bird is at height y. Here is a bird, and this is yes. Bird is here. This is the fish, and this height is given y. The bird is flying at the height y from the surface of water in the air. Now bird is watching the fish, कि इसको खाना है मेरे को, and fish is watching the bird, कि how to escape. Okay. So इसमें ये हमें find करना है कि what is the distance of the fish from the bird. What is the distance of the fish from the bird? So when bird is in air and fish is in water, so this means जो fish है, it will appear to the bird at the same depth or at different depth. Yes, it will be. Sparsh is saying, sir, it will be at different depth. So that depth will be, yes, apparent depth. Okay, apparent. So वो उसको, because fish is in water and water has its own diffractive index. So fish जो है bird को थोड़ा ऊपर दिखाई देगी, थोड़ा actual depth से ऊपर raise दिखाई देगी. Okay. So this means fish will see the apparent depth of the bird will see the apparent depth of the fish. Okay, and this is y. So we have to find the distance of the fish from the bird. And distance कौन सा आएगा? Apparent distance. Okay, of fish from the bird. So now given क्या है? Height of bird is y from the interface, and depth of fish, it is x, and refractive index of water, it is mu w. ये हमको given. To find क्या करता है? Distance of fish from bird. ये important देखिए, ये important. Distance of fish from the bird. Distance of fish from the bird means bird is watching the fish. This is important, that bird is watching the fish. So when bird is watching the fish, the rays of light are coming from fish. Fish से rays of light आ रही हैं. ठीक है, these are coming to the rarer medium, air में आ रही हैं, and this is the denser medium. तो देखिए इसमें कैसे करेंगे. So first of all we have to find out the apparent depth of the fish here. Now we should write down, since we know that a refractive index of the medium, here it is water, is equal to real depth upon apparent depth. So here apparent depth कितना होगा? Therefore apparent depth will be here, real depth is upon refractive index here. So real depth is here it is x, and apparent depth is refractive index is कितना है? This is mu w. ये आ गया हमारा. So this is the apparent depth of the fish here. Okay, it is the refractive index, so there will be it will be less. तो फिश कहीं आपको बर्ड को यहाँ दिखाई देगी, ओके, या ये पोजीशन हो सकती है, ऊपर दिखाई देगी एक्चुअल पोजीशन से. तो देयरफॉर क्या लिखेंगे? डिस्टेंस ऑफ फिश फ्रॉम बर्ड. ओके, दिस विल बी y. कितना है ये? पूरा y है. So this is y plus this is the apparent depth. This is x upon mu w. So this will be the distance of the fish from the bird. So y plus x w. So y is the distance of the, or we can say height of the bird from the interface. So this is y. So simply ये y हो गया. And then fish का जो apparent depth हो गया, that is x upon mu w, where w is water here. Okay, refractive index of water. So this way we can find out the distance of fish from the bird. Okay, so here again light is coming from the fish, and it is reaching to the eyes of bird. So apparent depth of fish will be taken, and this is the actual height of the bird. So this way we can find. Now if you are given value of x and y, then you can find out the actual height of the bird from the surface of water. From the surface of water. Okay. अगर ये हमको दिया होगा surface of water से, ये below water दिया है, तो हम find कर सकते हैं distance of fish from the bird. Okay. Now next question. Here you can see the fish is in denser medium. तो ये हमारा denser medium है ना, और this is rarer medium. तो ये जो फार्मूला बनता है कि ये आता है when object is in denser medium and observer is in rarer medium. Okay, so the फार्मूला क्या हो जाएगा यहाँ पर? So ये है when object is in denser medium and observer is in rarer medium. So then distance of the object from the observer, then होगा, या लिख सकते हैं हम height of, or we can say distance. We should write down distance. Okay, so distance of object from observer, it will be here y plus x upon refractive index of the medium, in which object is lying. Here x is the depth of the object in the denser medium, and y is the height or distance of the object in the rarer medium from the interface. Okay, now next, अब इसमें अगला जो केस करने जा रहे हैं, that is when observer is in denser medium and object is in rarer medium. तो उसमें क्या होगा कि now fish is watching the bird, observer is fish and object is now bird. So in this case, how shall we find the distance of the bird from the fish? So now this is the next question. Now next question, here it is question number 5 here. This is question number 5. Now you can see diagram is same, but the question has changed here. We have to find out the distance of the bird from the fish. Now in previous case, the bird was watching the fish. Now in this case, fish is watching the bird. कि fish को bird से बचना है, इसलिए वो scared है ना, डरी हुई है, तो उसको बचना है. वो देख रही है कि कितनी हाइट पर हमारा bird उड़ रही है, कि मुझे उससे बचना है. ठीक है. So now fish is watching the bird. So this means light rays are coming from bird, okay, to fish. तो ये rarer medium है, denser medium है. Okay, तो rarer to denser medium आ रही है. तो rays are coming from rarer medium to denser medium. तो bend होंगी इधर. ठीक है, या फिश की आइज में पहुंचेंगी। तो ये रेज है, इसमें दीज रे इफ इट इज यस इट appears to be फ्रॉम द हायर पोजीशन, ऊपर की थोड़ा हायर पोजीशन से आ रहा है। तो वी आर नॉट गोइंग टू डिस्कस इट इन डिटेल, बट इन दिस केस हाउ डू वी फाइंड नॉर्मल शिफ्ट। अब नॉर्मल शिफ्ट ये हो जाएगा, कहां से रेज आ रही है, ओके ये। तो दिस इज द एक्चुअल पोजीशन ऑफ द बर्ड, लेकिन बर्ड उसको थोड़ा ऊपर दिखाई देगी, है ना। तो दिस विल बी द नॉर्मल शिफ्ट वी हैव डिस्कस्ड इन प्रीवियस सेशन हियर, राइट। इसमें नॉर्मल शिफ्ट ऊपर होगा, ठीक है, फिश का ऊपर, ऐसे इसमें बर्ड का नॉर्मल शिफ्ट ऊपर की तरफ जाएगा हियर। तो नाउ ऑब्जेक्ट इज इन डेंसर मीडियम। तो नाउ object is in rarer medium, okay, rarer medium, and observer is in denser medium। तो फिश यहाँ पर ऑब्जर्वर है, ये डेंसर मीडियम में है, और बर्ड जो है हमारा ऑब्जेक्ट है, ये रेयर मीडियम में। तो इस केस में देखिए हमारा नॉर्मल शिफ्ट क्या होता है। इन दिस केस नॉर्मल शिफ्ट, तो देयरफॉर हम इसको बस इतना याद रखेंगे फार्मूला है, नॉर्मल शिफ्ट इज इक्वल टू, यस क्या होगा ये, हाइट, दिस इज द हाइट, ये हमारा h and mu minus 1, mu is the refractive index। तो h यहाँ पर कितना दिया है, दिस इज y, height of the bird। तो इसको हम लेंगे आपका y, and here refractive index of the medium minus 1। तो मीडियम हमारा यहाँ पर क्या था, यहाँ पर ये है वाटर। तो यहाँ पर वाटर है तो वाटर लेंगे, अदरवाइज जो भी मीडियम है, गिलास है तो यहाँ पे गिलास का रिफ्रैक्टिव इंडेक्स लेंगे। तो इट इज y mu m minus 1। दिस इज द नॉर्मल शिफ्ट। सो व्हाट इज द टोटल हाइट, जो इसको बर्ड को, इसको फिश को दिखाई देगा, बर्ड कितनी ऊंचाई पर देगा, इस अपनी ऊंचाई से ज्यादा ऊंचाई पर बर्ड दिखाई देगा। तो देयरफॉर टोटल या हाइट ऑफ बर्ड, ये क्या होगा, तो दिस इज y प्लस नॉर्मल शिफ्ट। तो ये आपका हो जाएगा y प्लस y mu m minus 1। तो व्हाट डू वी गेट हियर, तो ये y, और देखिए यहां पर आ जाएगा y प्लस y इंटू म्यू m माइनस y। तो y इसमें फिर कैंसिल आ गया, और ये आता है हमारा y इंटू म्यू m। तो रिफ्रैक्टिव इंडेक्स ऑफ द मीडियम y इंटू म्यू m। So now height of the bird which is seen by the fish is here। तो fish का जो depth है, this is x। तो therefore लिखेंगे यहां पर distance of bird from fish, it will be fish का जो depth है, this is x प्लस ये जो टोटल हाइट ऑफ द बर्ड, तो दिस विल बी y इंटू म्यू m। सो दिस विल बी द आंसर हियर। तो नाउ इफ यू आर गिवन द डेप्थ x की वैल्यू दी है 15, 16, वट एवर वैल्यू इज गिवन, इफ वैल्यू ऑफ y इज गिवन, देन वी कैन फाइंड डिस्टेंस ऑफ बर्ड फ्रॉम द फिश। ओके, फ्रॉम द फिश मीन्स फिश इज वॉचिंग द बर्ड नाउ। तो दिस इज x मीन्स डेप्थ ऑफ द फिश plus y, height of the bird from the surface of water, into refractive index of the medium। So this is the formula to solve the question। So please note it down, hurry up। Yes, done। So this will help you to solve many numericals। Now we are going to solve one numerical based on this question। Okay, now let's do the numerical। Now write the question। The question is this, there is a pond, again we are talking about the same case here। So this is the pond here, ये हमारा pond है यहाँ पर, and a bird is flying here। यहां पर एक बर्ड उड़ रही है, दिस इज द बर्ड बी, एंड हियर इज अ फिश, इसके अंदर यहां पर फिश है। ओके, यहां पर हमारा है fish, and the height of the bird from the interface surface of the water, it is given 120. It is given 120 from here. This is 120, and here the depth of the fish inside the water, it is given how much? It is given 60. ये हमको 60 दिया है, 60 meter. This is 120 meter. Now, so height of the bird from the interface is given and depth of the fish from the interface is given. So I am writing here height of bird from interface. It is 120 meter and height. Oh, sorry, depth. Now I got depth. Depth of fish from interface, it is 60 meter. And refractive index of the water, refractive index of water, and here I am writing like this, refractive index of water, it is given 4/3. तो हमको दो चीजें फाइंड करनी है। ओके, so we have to find out the distance of the bird from fish, distance of bird, or we can say height of the bird seen by the fish. तो पहला फाइंड करना है height of bird from fish. Okay, and second फाइंड करना है हमको distance of fish from bird. ओके, ये हमको फाइंड करना है। तो नाउ सॉल्यूशन देखिए, तो फर्स्ट केस है हाइट ऑफ बर्ड फ्रॉम फिश, मींस फिश इज वाचिंग द बर्ड, फिश इज वाचिंग द बर्ड। एंड सेकेंड केस में देखिए क्या है, डिस्टेंस ऑफ फिश फ्रॉम द बर्ड। ओके, दिस मीन्स बर्ड इज वॉचिंग द फिश, दोनों एक दूसरे को देख रहे हैं। बर्ड जो है वो खाना चाहती है फिश को और फिश बचना चाहती है बर्ड से, तो दोनों एक दूसरे को देख रहे हैं। तो दोनों का डिस्टेंस हमें निकालना है कि फिश का डिस्टेंस जब बर्ड देख रही है तो क्या होगा, और जब फिश बर्ड को देख रही है तो उसका डिस्टेंस कितना होगा ओके बर्ड से। तो दिस वी हैव टू फाइंड। तो नाउ लेट्स स्टार्ट द क्वेश्चन आंसर। नाउ फर्स्ट पार्ट, हाइट ऑफ बर्ड फ्रॉम फिश। तो इससे प्रीवियस जो हमने क्वेश्चन किया था उसी की हेल्प हम यहाँ पर ले लेंगे। ओके, सो नाउ व्हेन ऑब्जेक्ट इज इन height of bird from fish, object is in denser object is in rarer medium, observer is in denser medium, है ना। तो ऑब्जर्वर जो है फिश वो डेंसर मीडियम में है और बर्ड जो है ये रेयर मीडियम में है। तो इन दिस केस हमारा डिस्टेंस क्या होगा देखिए। ओके, तो देयरफॉर यहां लिखेंगे नाउ सिंस वी नो दैट ओके when observer in denser medium and object is in rarer medium, इसमें क्या होगा देखिए। तो इस केस में जो हमारा टोटल जो डिस्टेंस होगा, डिस्टेंस ऑफ बर्ड और वी कैन से हाइट ऑफ बर्ड फ्रॉम फिश, हाइट ऑफ बर्ड फ्रॉम फिश। तो ये क्या हो जाएगा आपका देखिए, विच फार्मूला वी यूज, यस कौन सा फार्मूला यूज किया था, जस्ट ट्राई टू रिकॉल। यस गॉट इट। यस सो फार्मूला आपको याद आ गया। तो दिस इज 120 हो जाएगा, ये अगर हमारा h है, दिस इज h, अगर हम इसको h ले लें दिस इज h and this is x हमारा. तो this will be h into mu m plus x. Okay. So mu m is the refractive index of the medium and x is the depth of the fish here. तो fish हमारा है 60 plus h हमारा कितना रखा है? This is 120. Refractive index of water is here 4/3. So here it will be 3 4 12 and it will be how much? 3 4 12, 4 4 60. 160 plus 60. So it is 120, no? Yes, 120. 160. So it will be 220 meter. So bird will appear to fish at the height of 220 meter. Yes, any doubt? So the bird will appear to fish at the height of 220 meter. And this, ये जो हमारा आया 120 into 4/3, this is the apparent 160. It is the apparent height of the bird from fish. तो ये जो from the surface of water, from the surface of water. तो ये 120 की जगह जो bird जो है, अगर हम यहाँ से देखेंगे तो ये 160 पर दिखाई देगा. और टोटल जो है डिस्टेंस होगा बर्ड का फ्रॉम फिश, इट विल बी 160 plus 60, 220 meter. I am sure you must have noted it. Now we are going to do the second part. Now second part. Now we know that when now bird is watching the fish. So now distance of fish from the bird. Now bird is watching the fish. तो जब bird fish को देख रही है तो rays of light are going from fish to bird, from denser to rarer medium, denser to rarer medium. ठीक है ना? So उस केस में देखिए क्या होगा. So when object is in denser medium and observer is in rarer medium, तो इस केस में क्या होगा देखिए. तो इस केस में जो हाइट होगा, ओके, तो हाउ फार दिस फिश इज विजिबल टू बर्ड. तो बर्ड को फिश कितनी दूर दिखाई देगी अपनी पोजीशन से. तो इस केस में फार्मूला क्या लगता है? इस केस में फार्मूला को क्या होगा? डिस्टेंस बिटवीन डिस्टेंस ऑफ फिश फ्रॉम बर्ड. डिस्टेंस ऑफ फिश फ्रॉम बर्ड. तो ये क्या होगा देखिए. Yes, anyone? What should be the distance of in this case? Yes, it will be how much? ये तो रहेगा पूरा. This is y plus, in this case it will be x upon refractive index of medium. So refractive index of medium, here medium is water. So we shall write down the refractive index of water here. Or we can write down here y plus x upon refractive index of water, and it will be how much? Distance 120 plus it is 60 into, yes, it is 4/3. So it will be कितना हो जाएगा ये? In this case it will be 120 plus 60 into 3/4. Here it is 15. It is 15 and it will be 120 plus 45 and total will be how much? 165 meter. तो ये जो फिश है, फिश को जो है बर्ड को कितने डिस्टेंस पर दिखाएगी? 165 पर. लेकिन यहां पर देखें तो 120 plus 60 180 आता है. 120 plus 60 it is 180. तो एक्चुअल में जो फिश है, इट इज एट द डिस्टेंस ऑफ 180 फ्रॉम द बर्ड, बट इट appears at 165 सेंटीमीटर 165 मीटर फ्रॉम द बर्ड. तो ये इसको, दिस इज द अपरेंट डिस्टेंस, एक्चुअल डिस्टेंस इज 180. तो फिश तो दिखाई देगी इसको 165 पर मीटर होगी, फॉर इफ इट जंप्स इनटू वाटर तो इसको पकड़ नहीं पाएगी, वो उतने से ज्यादा टाइट होगी. ओके, सो आई एम श्योर नाउ यू कैन डू सम क्वेश्चंस एट होम आल्सो. These questions are important for multiple choice questions also. उसमें भी ऑप्शन दिए सकते हैं, and then you can easily find out the answer. So now I am giving you 3 questions for homework.